Hello friends, welcome to the Agriculture channel. So today we are going to discuss about the important concept behind the soil texture. So here soil texture means the relative proportion of sand, silt and clay. That means first of all you should know what do you mean by soil, sand, silt and clay. Actually, where these sand, silt and clay, these are called as soil separates. And in this case, we can go for, there are two institutions we can say. One is United States Department of Agriculture, another is International Union of Soil Science. So, based upon the United States Department of Agriculture, the soil separates are classified based upon the size of the separate, and this size, the whatever the parameter is given, this is the diameter and the unit is in millimeter. So if the particle size or the soil separate size is less than 0.002 millimeter, then we call it as clay particle. If it is sealed, then 0.002 to 0.05. So now, according to USDA, that is United States Department of Agriculture, it is classified the sand into, you can see here, into five group. Into five group, the sand will be classified. That is very fine sand, medium sand, coarse sand, very coarse sand, and at last there will be gravel. So gravel will be more than 2 millimeter. If particle size is more than 2 millimeter, then we will call it as gravel. This is the very simple thing. Then next, coming to IUSS, that is International Union of Soil Science. It has classified the soil separate. If it is less than 0. It is very much important, because in case of India, we are following this classification. We are following the classification given by International Union of Soil Science. So here the clay particle, if the size is less than 0.002, then just multiply 10, you will get the answer. Just multiply the 10, that is 0.002 to 0.02, that is silt, then 0.02 to 0.2 millimeter, it is fine sand. Then you can see here 0.222, it is coarse sand, and if it is more than 2, it is called as the gravel. So basically here you can say the gravels or pebbles normally 2 to 75 millimeter. This is the called as the gravel. But if we'll see about the stone, the stones are about more than 250 millimeter diameter in nature. But if we'll see cobbles, then it will be 75 to 250 millimeter. It is the particle size or soil separate size based upon the IUS. So the question is, India is following which type of classification, whether it is USDA or International Union of Soil Science. So India is following IUSS. So now the soil texture, the definition itself says that inside your soil system, inside your soil, you should first calculate what is the sand percent, what is the silt percent, and what is the clay percent. So first of all, you should calculate the percentage, then we can derive what is the soil texture. So here you can see, suppose I will say the clay, this is the clay soil. So the soil texture is clay soil. First of all, this is a triangle, and this is called as soil textural triangle. Soil textural triangle. Soil textural triangle, and this triangle was first given by Whitney. This given by the scientist Whitney, and later it was modified by Davis and Bennett. It was modified by Davis and Bennett, but initially it was given by Whitney. So here you can see the textural triangle is there. The triangle has three sides. At one side it will show the proportion of sand. Another side it will show the silt percentage. Another side we can see the clay percentage. So basically, if we will see what is the texture, there are different types of soil textures are there. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That means here we have 12 number of soil texture. Again, you can count this. Okay, so in the textural triangle we have 12 number of soil textures, and here majorly we are going for clay soil. So if I'll ask you, the soil with having texture of clay, in nature. That means most of the soils, here you can see the limitation though for the clay soil. Okay, that means the clay soil, if a soil will be called as clay soil, that means it must be more than 40%. You can see here more than 40% the clay percentage should be there. So basically you should find out what is the percentage of sand, percentage of silt and percentage of clay. So if a soil we will call as clay, then it's the clay content should be more than 40%. Again, if we here you can see in case of sandy loam, another is loam is there. As you know that loamy texture soil. So here the loamy texture soil means you can see 40% around this loamy percent, you can see 40% of sand particles. So here you can see this is the point of loamy texture soil, and here at least 40% sand, and here in this case 40% silt. Then remaining 20% you can see the clay particles. So you can see a ideal loam texture soil contains sand, silt and clay in 40% and 20%. This is called as the loamy texture soil. Okay, so now another important question. Okay, so if a soil, the texture name is sandy clay, you can see here the soil texture name is sandy clay. That means sandy clay, that means you can see here sandy clay means the sand content is very high. Here you can see the sand percent is very high, but the clay content is very less. That means if I will say sandy clay, that means the clay where sand is more dominant, the clay soil where sand is more dominant. Here you can see silty clay. In case of silty clay, the sand portion is very less, but silt content is very high as compared to the sand. So silty clay means the clay where silt is more dominant. Okay, again there is another concept. So here you can see, that sandy loam, another is loamy sand. But here you can see in case of sandy loam, the sand is about 70%, the highest is 70%, but loamy sand means the sand may go up to 85%. That means, and here you can see more than 85%, it will be called as sand. So a sandy soil means if the sand content is more than 85%. And if I will compare between two soils, sandy loam and loamy sand, in which case the sand content is more, it is nothing but the loamy sand. Okay, so now whatever the soil texture, you want to find out the sand, silt, clay percentage, yes or no. So for this, what you will do, we should go for two methods. One is, you can see, one is pipette method, another is Boyko's hydrometer method. This pipette method was followed by this IUSS, Indian International Union of Soil Science, followed pipette method. So there is two principles. There are two principles where we are going for measuring the sand, silt, clay proportion. The principle one is separation principle, means dispersion. Separation means what? Suppose this is my container, and in this case the soils are present. And inside the soil all sand, silt and clay all are present in united form. So dispersion means, first of all you should separate the sand particle, separate the silt particle and separate the clay particle. Then only we can calculate what is the percentage. So dispersion means separation of the soil particles, sand, silt, clay from, we have to separate them. And for dispersing, for this a dispersing agent is required, majorly sodium containing compound. So that means an element which will help in dispersion of the soil particles, the element is Na, that is sodium. Then after separation of these particles, Now we should go for settlement. We can go for sedimentation. The process is sedimentation. So two process, one is dispersion, another is sedimentation. Sedimentation means, as you know, that here we can you can write here in this case. So sedimentation means, suppose I will take a container. Suppose I will take a container. So in this container, the sand particles which are larger in size, then silt particle which are medium in size, then clay particle which is small in size. That means whatever the already disposed means already whatever the sand, silt, clay all are separated. Now sedimentation means based upon the which law? Based upon the Stokes law, the velocity means downward movement of the velocity. As you know that under and so here water is present inside the beaker, and whatever the soil particles they are in separated form. So if this is the Stokes law says that velocity of the downward movement of the particle is depend upon the square of the, it is directly proportional to the square of the radius of the particle divided by this is the viscosity of the water. This is eta means viscosity. So this is our case is how the velocity or the downward movement, as you know that it will settle down after some time. Here water is already present, here water is present, okay, here water is present, you know, inside the beaker, and you have different types of particles. Now the question is, as you know that after some time the sand particle will settle down, then silt will settle down, then at last clay will settle down. Why? Because here the velocity is more if the radius will be more. So as you know that sand particle radius is more, the radius is more in case of sand particle, then silt particle, then clay particle. That means higher the radius means higher will be the velocity. This is the velocity under which the sand particle will first settle down. The sand particle will first settle down, then silt particle will be settled down, then clay particle will be present over the upper surface of the soil, you can say, or upper surface of the beaker. So now you are using Boyko's hydrometer to find out the sand percent, silt percent, and clay percent, and then accordingly you can use the textural triangle to find out the soil texture. Okay. So basically whatever the sand and silt you are using, the soil separates. This sand and silt both are quartz dominant soil separates. So quartz means silica oxide, that is SiO2 rich compounds, that is sand and silt. And the thing is that the sand contains most of the inactive and insoluble element. Whatever the elements present in the sand, these are inactive as well as insoluble. As it is insoluble inside the sand, so it cannot help, it cannot release any nutrient to the plant. But with respect to, if we will say with respect to silt, the silt somehow in the silt is somehow provide potassium to the plant, because the silt contains some potassium bearing mica, hence silt somehow provide potassium to the plant. Coming to the clay particles, these clay particles instead of sand, silt, the clay particles are very much active in nature. And the clay particles you can see the montmorillonite clay 2:1 type, kaolinite 1:1 type. These montmorillonite and kaolinite, and these are aluminum silicate minerals, and they are rich in sodium, iron, magnesium, so that they can release the nutrient to the plant. With respect to elite clay minerals, these are hydrous mica, these are potassium aluminum silicate, these are also release enormous amount of potassium. So this is the thing we have to go for soil texture. So now the most important question it is asked is that whether the soil texture is a basic property of the soil. The answer is yes, it is the basic property of the soil. Always remember, it is the basic property of the soil, because the soil texture cannot be changed. The soil texture of a soil cannot be changed or it cannot be altered because it is the basic property of the soil. This is most important question asked in the examination. So I hope you have understood some important concept regarding to soil texture. Thank you so much.